Welcome students. This is part 7 video on Unit 4 electromagnetic induction. In this session, you will be exposed to the construction and working of an AC generator. The phenomenon of electromagnetic induction has been technologically exploited in many ways. An exceptionally important application is the generation of alternating current, that is AC. An AC generator or an alternator is energy conversion device. It converts mechanical energy into electrical energy. In commercial generators, the mechanical energy required for rotation of the armature is provided by water falling from a height, for example from dams. These are called hydroelectric generators. Alternatively, water is heated to produce steam using coal or other sources. The steam at high pressure produces the rotation of the armature. These are called thermal generators. Instead of coal, if a nuclear fuel is used, we get nuclear power generators. Here in this image, it is understood that mechanical energy of this rotating coil is being converted into electrical energy. The Yugoslav inventor Nikola Tesla is credited with the development of the machine. Shall we know more about him? He is genius. He conceived the idea of the rotating magnetic field, which is the basis of practically all alternating current machinery and which helped us in the age of electric power. He also invented, among other things, the induction motor, the polyphase system of AC power, and the high frequency induction coil, that is Tesla coil, used in radio and television sets and other electronic equipment. The SI unit of magnetic field is named in his honor. Let us learn the principle behind the machine AC generator. Alternators work on the principle of electromagnetic induction. See, here I use the word alternator or AC generator because there are lots of differences between a generator and an alternator. Generator can generate both AC and DC currents, while an alternator or AC generator can generate only alternating currents. There are many more differences also. So, we should often use the word alternator, which means only for alternating current generation. So, what's the principle of AC generator or alternator? The principle behind the device is electromagnetic induction. It is a well-known fact that only the relative motion between the conductor and the magnetic field changes the magnetic flux with the conductor, which in turn induces an EMF, and the magnitude of the induced EMF is given by Faraday's laws of electromagnetic induction, and its direction is given by Fleming's right-hand rule. Hope students, you have learnt already in previous videos about Faraday's laws of electromagnetic induction and Fleming's right-hand rule, isn't it? Here we have additional information about the types of AC generator or alternator. An alternating EMF is generated by rotating the coil in a magnetic field. See, here magnetic field is permanent. Only the coil is rotated in a permanent magnetic field. In the sense, stationary magnetic field. அதாவது magnetic field stationary வச்சிட்டு coil rotate பண்றோம். இங்க பார்த்தேன்னா stator இருக்கு. அதாவது here coil is stationary, magnetic field is rotating. So this is a rotating coil type magnet and this is rotating field type magnet. So in our lesson we are going to learn about this rotating field type magnet where the coil is going to be kept stationary. Hope you understand, students. See, this first method is used for small AC generators, while this rotating field type is employed for large AC generators. The rotating field method is the one which is mostly used in power generations, power stations. Here we are going to learn about some components of AC generator. An alternator consists of its components: stator, rotor, brush box, slip rings. Few more parts I have shared. You see bearings, rectifier diode packs, regulators, and this is a pulley for rotating purpose, and so on. Alternator consists of two major parts. Two major parts which comes under its construction. Which are the two major parts? One is stator, another one is rotor. As the name suggests, stator is stationary while the rotor is rotated inside the stator. This is the picture showing clearly the components of alternators. இங்க பார்த்தேன்னா end covers இருக்கு. அதுக்கு just முன்னாடி regulators வச்சிருப்பாங்க. இது rectifiers, DC மாத்தக்கூடியது. அடுத்து இது statorங்கிறது stationary part. அடுத்து அந்த ஸ்டேட்டருக்குள்ள ரொட்டேட் ஆகக்கூடிய பார்ட் தான் ரோட்டார். அடுத்து இந்த ரோட்டாரோட ஷாஃப்டோட இங்க அட்டாச் ஆயிருக்கிறது பேரிங்ஸ். உள்ளுக்குள்ள பால் பேரிங்ஸ் இருக்கும். இது பிராக்கெட்ஸ்னு சொல்லுவாங்க. இந்த பார்ட்டுக்கு பேரு புல்லிஸ். Yes, here we have another picture. You see this is stator core, stator winding. These are slip rings, load resistance, and this is rotor core and brushes, and we need excitation power supply. What is taken out? Shall we learn in detail about the one of the major parts, that is stator. As the name suggests, stator is stationary. The stationary part, which has armature windings mounted in it, is called the stator. It has two components. One is stator core and another one is armature winding. What is this stator core? You see, it is made up of iron ore, steel alloy. It is a hollow cylinder and it is laminated to minimize eddy current loss. Dear students, we have learned the meaning of eddy currents in previous videos, isn't it? Eddy currents is undesirable. There will be loss due to the eddy current. It should be minimized. How it is done? By laminating. See here, the slots are cut in inner surface of the core. Why? Just to accommodate armature winding. Then what is an armature winding? It's the coil wound on the slots. So this part is known as slots. Coming to the next major part of an alternator, which is the rotor. As I already told, rotor rotates inside the stator. Rotor contains magnetic field windings. You are able to see magnetic field windings. And the magnetic poles are to be magnetized. This is done with the help of a DC source. Ends of the field windings are connected. You may see the ends are connected to the pair of slip rings. Field windings ends are connected to the pair of slip rings, and these slip rings are attached to the shaft. You may just observe here this shaft. This is the rotating part known as shaft, about which the rotor rotates. These slip rings rotate along with the rotator. எப்பெல்லாம் வந்து அந்த ரோட்டார் சுத்துதோ அப்போ அது கூட சேர்ந்து இந்த slip rings சுத்தும். In order to maintain connection between the DC source, இந்த DC supplyக்கும் இந்த armature field windingsக்கும் கனெக்ஷனை மெயின்டைன் பண்ணுறதுக்கு 2 brushes வச்சுருப்பாங்க. இந்த 2 brushes ஓட வேலை என்ன? They are used which continuously slide over the slip rings. And we will discuss now the construction of single phase AC generator. Before then, why should we prefer stationary armature rotating field alternator? அதாவது armature is stationary, coil stationary, magnetic field is rotated. அந்த type of alternator choose பண்றதுக்கு என்ன காரணம்? What are the advantages? So this construction has many advantages, because here current is drawn directly from the fixed terminals on the stator. Here we need not use the brush contacts to take current output. And insulation also done in an easier manner. And the number of sliding contacts known as slip rings also reduced. Here sliding contacts are used only for low voltage DC source. These armature windings can be constructed more rigidly, very strongly, to prevent deformation due to any mechanical stress. Moreover, this stationary armature rotating field type, as I already told, it is one of the high voltage machine. It just prevents short circuits and arc overs. These are some of the advantages. Now getting into the discussion of construction and working of single phase AC generator, and we have been given 3 phase AC generators also, that will be discussed in the following sessions. Do you remember what is the expression for induced EMF at any instant? It is epsilon is equal to epsilon m sin omega t, where epsilon is the induced EMF at any instant and epsilon m is the maximum induced EMF. And here this omega t represents the angular displacement made. Alternating current is given by small I is equal to Im sin omega t. These are the 2 expressions that to keep in our mind while learning the concepts of Working of a single phase AC generator. And this is the picture showing loop PQRS and field magnet in its initial position. என்ன ஞாபகத்தில் வச்சிருக்க? இங்க மேக்னெட் தான் என்ன பண்ணும்? ரொட்டேட் ஆகும். ஃபீல்டு மேக்னெட் தான் ரொட்டேட் ஆக போகுது. காயில் எப்படி இருக்க போகுது? ஸ்டேஷனரியாக தான் இருக்க போகுது. இதை நீங்கள் ஞாபகத்தில் வச்சுக்கோ. So, this is a simplified version of AC generator. A single turn rectangular loop PQRS is mounted on the stator, and the field winding is fixed inside the stator, and it can be rotated about an axis perpendicular to the plane of the paper. As I already told, keep in your mind, PQRS is stationary and it is perpendicular to the plane of the paper. When you just excite the field windings, magnetic field is produced around it. ஏதாவது ஒரு எக்ஸைட்டேஷன் எனர்ஜி கொடுத்தோம்னா ஃபீல்டு வைண்டிங்ஸ்க்கு அங்கே மேக்னெட்டிக் ஃபீல்டு ப்ரொடியூஸ் ஆகும். லெட் த மேக்னெட்டிக் ஃபீல்ட் இஸ் ரொட்டேட்டட் இன் clockwise direction. அஸ்யூம் பண்ணிக்கிறோம். எப்படி ஃபீல்டு மேக்னெட் clockwise directionல ரொட்டேட் ஆகிறதாக எடுத்துக்கொள்வோம். சம் எக்ஸ்டர்னல் மீன்ஸ் ரொட்டேட் பண்ணணும் நம்ம. And this is the initial position. Here the magnetic field is horizontal. At that instant, the direction of the magnetic field. See, this is the direction of the magnet. The magnet is horizontal, and so direction of the magnetic field is perpendicular to the plane of the loop PQRS. As this B vector is perpendicular to this plane of PQRS, okay, and its initial position, what's the displacement, angular displacement made? That is omega t equal to 0. Yes, and the induced EMF is also 0 in its initial position. So we will learn about the graphical representation of variation of induced EMF with respect to the time angle in the later part of the session. Let us learn in detail about the working. As I have just shared the cropped figure to make you clear about the concept. In the initial position, see, B vector is perpendicular to the plane of the loop, and so the angle is 0. So, initial position of the field magnet is horizontal, and the direction of magnetic field is perpendicular to the plane of the loop, and because of the value of omega t equal to 0, induced EMF is 0. Suppose the magnet starts to rotate. The field magnet rotates through now 90 degree. இங்க இருந்த field B இப்போ இங்க போயிருக்கு, 90 degree rotate ஆயிருக்கு. And the magnetic field now comes parallel to PQRS. Am I correct? The induced EMF across PQRS would be maximum in this case because omega t is pi by 2. When we substitute that epsilon is equal to epsilon naught sin omega t, instead of omega t it is sin 90, and so it is maximum. Why it is maximum? We can say they are connected in series All armature conductors are connected in series to form a single circuit, and so EMFs are added up and the direction is given by the Fleming's right hand rule. Care to be taken while applying this rule. Usually thumb indicates the direction of motion of the conductor with respect to the field, but it is clockwise rotating poles. No? For clockwise rotating poles, the conductor appears to be rotating in anti-clockwise. So, hence, thumb should point to the left. Here, we need to keep our thumb which points to the left. The direction of induced EMF is at right angles to the plane of the paper. So, to the plane of the paper, it would be right angle. So, for PQ, it is inwards. For RS, it is outwards. So, what about the direction of the current according to Fleming's right hand rule? It is along PQRS. Okay. Now, if it is rotated further, and so for the rotation of 180 degree from the initial position, 180 degree from the initial position, we say 180 degree from the initial position. Why? This position is initial, and when it reaches here it is 90. Now it has come over here that it has described 180 degree from the initial position. This is the 180 degree field. So here the field is again perpendicular to PQRS, and the induced EMF becomes 0, and mathematically sin 180 would be 0. Okay. Now coming to the angular position of 270 degree. If a field magnet எப்படி rotate ஆயிருக்கு, initial position இருந்து 90க்கு வந்துச்சு, 90ல இருந்து 180க்கு வந்துச்சு, இப்போ இங்க வந்திருக்கு. அப்போ அந்த 270 degree position becomes again parallel to PQRS. இப்போ பார்த்தீங்கன்னா இந்த 270, அதாவது இந்த 3 pi by 2 அப்படிங்கிற பொசிஷன் வந்து PQRSக்கு எப்படி இருக்கு, parallel-ஆ இருக்கு. 3 pi by 2 பொசிஷன் PQRSக்கு parallel-ஆ இருக்கிறதுனால induced EMF இங்கேயும் மேக்ஸிமமாக இருக்கும். ஆனால் டைரக்ஷன்ஸ் பாரு, according to the Fleming's right hand rule, direction is reversed. இங்கே பார்த்தீங்கன்னா direction is along, direction of the current is along SRQP. Okay. இப்போ பார்த்தீங்கன்னா முதல்ல ப்ரீவியஸ் ஸ்லைடில் டைரக்ஷன் ஆஃப் த கரண்ட் PQRS வந்துச்சு. அடுத்த ஹாஃப் சைக்கிளுக்கு எப்படி வந்துருச்சு, SRQP வருது. அப்போ it changes in direction in negative sign. That is why it is named as alternating. One half cycle positive, another half cycle negative. That is why it is an alternating current. Okay. Now, the field magnet has completed one full rotation. On the completion of rotation, one full rotation 360 degree, then the induced EMF becomes 0. Mathematically it is 0 because sin omega d 2 pi. And so it is 0. Now see here, the field magnet has reached the same position. So it has described 360 degree. அப்போ இதைத்தான் ஒரு full rotation சொல்கிறோம். எப்போ டைரக்ஷன் பற்றி பேசுவோம், எப்போ கரண்ட் இன்டியூஸ் ஆகுதோ அப்போ மட்டும்தான் டைரக்ஷன் பற்றி பேசுவோம். ரைட்? So shall we learn now the graphical representation or variation of induced EMF, with the respect to time angle. See, this is maximum and this is positive induced EMF, and this is for the negative maximum. This is positive maximum and this is negative maximum. So for the initial position where the field magnet has not started to rotate, time t is equal to 0, omega t 0, that is why it is epsilon is 0. And when it starts to rotate, when it reaches omega t pi by 2, it is maximum along the positive direction when the angle is 90 degree. On further rotation, it reaches 180, again it is 0. So this is represented by point P, where omega t is equal to pi. On further rotation, it reaches, or it described an angle to 70 degree, 3 pi by 2. So its value is negative maximum, represented by point C. Again, when it completes one full rotation 360 degree, EMF, induced EMF is 0. See here the variation of induced EMF along positive direction and negative direction alternatively. So, from this graph it is clear that EMF induced in PQRS is alternating in nature, and when it finishes one rotation, then it is called one cycle. Hope you have understood, students, about polyphase AC generator and three-phase AC generator and their advantages will be discussed in the later session of this lesson. Thank you.